Hello everyone. So for today we'll continue with a new chapter. It's chapter 4. So in chapter 3 we already talked about the probability distribution consisting of discrete random variable and also continuous random variable. So here we will see some specific cases. So we call it a special probability distributions. So in this chapter we'll take a look at 3 different distributions. One is called uniform distribution, which we will take a look today. And the second one we'll take a look later after your test. It will be the binomial distribution and also the Poisson distribution. Okay. But for today, let's start simple with the discrete uniform distribution. So what is discrete uniform distribution? So a discrete uniform distribution, as the name suggests, is a discrete random variable. Okay, so you can count it 0, 1, 2, 3, and so on. And it is a uniform distribution. So a uniform distribution means that the probability for all the values are the same. Okay, that is the very important part. So the probability for all the values for all x is the same. It's a constant. It is a uniform. Okay, for example, we have rolling a dice. Okay, if you're rolling a dice, since a dice have 6 faces, okay, so the probability of you getting any number from 1 up until 6 is 1 over 6. Okay, so the probability of getting any number for x, any number from 1 up until 6, 6 is 1 over 6. Or maybe the probability of choosing a red pen from 3 red pens. So you have 3 red pens, so the probability of you choosing 1 pen is 1 over 3. Okay, so here's a graph for a uniform random distribution. So you have A as your lower value and B as your higher value, or the higher interval. You have an interval, like for example earlier we have, if we roll a dice, we have the numbers that x can take is from 1 up until 6. So in this case, A would be 1 and B would be 6. Okay. And for all of the values of x, you will have 1 over n probability. Okay. For example, earlier we have, if we roll a dice, we have 1 over 6. Okay. So it is 1 over 6 for value of 1, for value of 2, value of 3, value of 4, value of 5, and also value of 6. The probability of you getting any values is equal to 1 over 6. They are all uniform. That is why we call it as discrete uniform distribution. Okay. So here it is. Okay. We have is fx, so here we call it as probability mass function. Okay, probability mass function is because it is a discrete random variable, so we call it probability mass function. Previously in the previous chapter, we called the continuous random variable as the probability distribution function, or PDF. Here, if we're talking about discrete random variable, we call it as probability mass function, or in short is a PMF. Okay, PMF, probability mass function. So the PMF for the discrete uniform distribution is given by 1 over n, where n is the number of the values that you can take. So in this case, if we have x will be between a and b, and it will be 0 otherwise. Okay? And on any other values, the probability of you getting the value will be 0. For example, earlier, if we roll a dice again, I really like the dice example. The fx would be equal to 1 over 6. Okay, if you roll 1 dice, the probability of you getting any numbers between 1 and 6 would be 1 over 6. Okay, from 1 until 6, the probability of you getting the number would be 1 over 6. And it would be 0 otherwise. Okay. Like for example, you cannot get the value of 8 from one single throw of dice. okay, because the number 8 is not there. So the probability of you getting number 8 is equal to 0. Okay. And then we take a look at the expected value. Just remember, expected value means the average or the mean. So the average value is given by 1 over 2 multiplied with a plus b, where a and b is your lower and upper interval respectively. Okay. So again, in the case of your dice, it will be ex would be 1 over 2, a is 1, and then b is 6. So if you calculate this, you'll get the answer of 3.5. Okay. Is this correct or not? Okay, you can check by just imagine, right? Because one dice have numbers 1 until 6. So if you keep on rolling the dice, so what is the average number that you will get? So if you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 and then divide by 6, you will get 3.5. That is the average. So that is what we are calculating here. We are calculating the average. But here it will be an easier way lah. So you just take 1 over 2, multiply with a plus b. Okay, the lower limit plus with upper limit. And then the variance. Okay, the variance is also special here. We don't use ex square. I mean, we kind of do, but here is the simplified version for discrete uniform distribution. So we have this formula, n square minus 1 over 12, okay, where n is equal to the number of possible values for x, or you can get by b minus a plus 1. If earlier, for rolling a dice, we have 6 minus 1 plus 1, which is equal to 6. So 6 is your number of n, okay, number of possible values that you can get. So if you want to find the variance, we just put 6 here on n. So 6 square minus 1 over 12. Okay, so if you want to calculate the variance, you can just straight up use this formula. The formula is this, n square minus 1 over 12. Why it is minus 1 over 12? So that's the proof here. So right now you don't really need to know about this so far, but if you want to continue pursuing in higher level statistic, okay, you will definitely need to know this. Okay, maybe in your degree, or yeah, probably in your degree. Because I think I remember I learned this during degree. Yeah, so this is the proof. So it still use ex square minus ex square. Okay, but it has been simplified, and in the end you can just get n square minus 1 over 12. Okay, this is why it is a special distribution, because we can just straight up get the variance without having to use this formula up here. Okay, you can just use n square minus 1 over 12. Okay, you don't really need to know the whole thing, how to get from up here to down here, but just know that if you want to find the variance of discrete uniform distribution, you can just straight up use this formula, n square minus 1 over 12. Okay, this one is the example. So example of rolling a dice. So say that we are rolling a dice, and then we need to find the probability that an odd number appear when rolling the dice. Okay, so first of all, if you have this kind of question, just see what is the event that we are doing. What is the probability that we want to know? So we are rolling, since we are rolling a dice, so we know that a dice has 6 different sides, 6 different faces. Okay, and the face have numbers from 1, 2, 3, 4, 5, and 6. So we know that the values of x can be from 1 until 6. And so our function of our PMF, our probability mass function, will be given by 1 over 6. Okay, the probability of getting any number. So it will be 1 over 6. So the question asks us to find the probability that an odd number appears when rolling the dice. Okay, first of all, what is the odd number on the dice? So we know that the odd number is 1, 3, and 5. Okay, 1, 3, and 5. There's no 7 on dice, there's no 9 on dice, so those are not counted. Okay, so there's only counted 1, 3, and 5. So to find the probability that x in an odd number, we just add the probabilities of odd numbers together. So here, the probability of x when we get x equal to 1 is 1 over 6. And then px equal to 3 is 1 over 6 as well. And then px equal to 5 is 1 over 6 as well. Because this is a discrete uniform distribution, so their probabilities are the same, okay, no matter what the values are. So if we add those together, we will get 1 over 2. Okay, so the probability of you getting an odd number is 1 over 2. And then for question number 2, find the probability that the number appear when rolling the dice is less than 4. So we need to find the probability of x less than 4. So what is the values on the dice that is less than 4? So the values are 1, 2, and 3. So the probability for x equal to 1 is 1 over 6. Probability of x equal to 2 is 1 over 6. And also the probability of x equal to 3 is also 1 over 6. Again, we sum everything up together. So it will equal to 1 over 2. So that's how you find these probabilities. Okay. The third question is to find the expected value and variance. Okay, let's take a look one by one. Let's find the expected value first. So the formula is up here. So the expected value is given by 1 over 2 multiplied with a plus b. So what is our a and what is our b? Again, remember that a is the lower limit. So this is our a. B is the upper limit. So this is b. So to find our expected value, we just use this formula, just plug in the value. So a is 1, b is 6, and you get 7 over 2. So 7 over 2 is 3.5. 3.5. And then for the variance, we will use this formula, n square minus 1 over 12. Okay. So what is our n? So our n you can just find using this formula, b minus a plus 1. Either use this formula or you can just count one by one lah. Okay. So since the x can take values from 1 until 6, that means we have 1, 2, 3, 4, 5, 6. So n will be equal to 6. Or you can, if you want to use this formula, b minus a plus 1, you can use 6 minus 1 plus 1, which equals to 6. So our n is equal to 6, so we can just plug that into our values here, into our formula here. So 6 squared minus 1 over 12, we get 2.9167. So that is our variance. Let's take a look at another example. So here, we have 10 ping pong balls that are numbered 1 to 10 and placed in a bag. Okay? And then 1 ping pong ball is removed from the bag randomly. Okay? So we have 10 ping pong balls in a bag and we want to choose one randomly. So find the expected value and the variance. And then question B is find the probability that the number on the drawn ping pong ball is between 7 and 10. Okay? If you guys want to try first, okay, you can pause the video now and we'll discuss together in 5 seconds. 4, 3, 2, 1. Okay. I assume you guys have already tried this example. So let's discuss example 1a. So find the expected value first. So the expected value is given by okay. So we have we have ex. Okay, we want to find ex. So a is 1 and b is 10. Why a is 1, b is 10? Because they are numbered from 1 to 10. So our a is 1, b is 10, and we also have 10 ping pong balls. So our expected value would be 5.5. The variance of x, so we need to find number of n first. Okay, n. So again, here you can either use the formula or you just count them. If you want to use the formula is b minus a plus 1. So b minus a plus 1, so b is 10, a is 1, and then plus 1. So you get 10. Okay. So, or you can also just count the balls. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you know that n is equal to 10. So just plug in into this formula, you get n equals to 10. So 10 squared minus 1 over 12, you get 8.25. Okay. And then we also need to find the probability that the number on the drawn ping pong ball is between 7 and 10. Okay, so here we have 10 ping pong balls, and the probability of you choosing the ping pong balls are the same. It should be 1 over 10 because we have 10 ping pong balls. Okay, so our PMF, our probability mass function, is given by fx equal to 1 over 10. And this 1 over 10 is for the values of x from 1 until 10. Okay. So now the questions want us to find the probability that the number on the drawn ping pong ball is between 7 and 10. Okay, I guess it's not included 7 and 10. So between 7 and 10, it will just be number 8 and number 9. So we know that the PMF is 1 over 10 and they are uniform distribution. So the probability for all values are the same. So here, if you want to find the probability of x equal to 8, it will just be 1 over 10. Same goes for probability of x equal to 9. So also be 1 over 10. So add them both together, we will get 1 over 5. Okay. So lastly, here's your example, not example, here's task 4.1 from your book, okay, page 106. Okay, I want you guys to do this one first, and we'll discuss in 5 seconds. Just pause the video now if you want to give it a try. Okay, so I guess we can discuss now. So a telephone number is selected at random, and suppose X is the first digit of the selected phone number. Okay, so again here we need to know what is the event, what is the probability that we need to find. So we have a telephone number that is selected at random, and I'm guessing this telephone number can be literally any telephone number in the world, not just Malaysia, because Malaysia would be starting with 0, right? So that would be, you know, that it will be just 0. So I'm guessing this telephone number is for all telephone numbers in the world, so any number can start here. Okay? So it can be literally any number from 0 until 9. So values of x can be from 0 up until 9. Okay, so how many values that we have here? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 different digits, which means the probability of you selecting any number here would be 1 over 10. Okay, and x can be from 0 up until 9. So if the question wants us to find the probability that the first digit of the selected number is 8, okay, just one number, which is 8. So we find the probability of x equal to 8. So it's just a simple 1 over 10. Okay. For the second question, the question wants us to find the probability that the first digit of selected number is less than or equal to 3. So we know that we want P when x is less than or equal to 3. So it will be Px equal to 0, which is again 1 over 10. Px equal to 1 is 1 over 10, Px equal to 2 is 1 over 10, and then Px equal to 3 is also 1 over 10. And then if we want the probability for x less than or equal to 3, we just add all of these together, and then we will get 2 over 5. And similarly for question 3, you want the probability of the first digit of selected number is more than 7. So for more than 7, we just use Px equal to 8 and plus with probability of x equal to 9. So here you will get 1 over 5. Okay, the probability will just be the same. It's still 1 over 10 no matter what the numbers, no matter what the number is, as long as it is between 0 and 9. For example, if we have x equal to 10. So this one cannot. Why? Because the probability of x equal to 10 is equal to 0. It cannot happen that the first digit is number 10. It doesn't make sense, right? So yeah, so this one would be 0. So as long as x is between 0 and 9, the probability is 1 over 10. That's what I said. This discrete uniform distribution should be quite easy and straightforward. Okay, later, is there any? Oh, there's one more. Alright, so here we have the expected value. We want to find the expected value and the variance. Okay. So again, we're using the same PMF, the same probability mass function, and x from 0 until 9. So to find the expected value for EX, so our A would be 0 and our B would be 9. So just input the values. So 0 plus 9 is 9. This is wrong. Hold on, chat. One should 4.5. Okay, so 9 over 2 is equal to 4.5. Okay, and then to find the variance, we're using this formula, n squared minus 1 over 12. So we just need to find n. So how to find n? Either you use this formula, which is b minus a plus 1. So b is 9, a is 0, and then you plus 1. So you get 10. Or you just count how many possible values are there in x. So you have 0, 1, 9, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10 different values. So just input n here. So you get 10 squared minus 1 over 12. So you get the variance of 8.25. Okay. So just be extra careful here that n is not 9, yeah? N is not 9. Yes, n is, where is it? Okay. N is only goes up until 9, but we have a total of 10 different digits, okay? 10 different values that we can use, including 0. So n should be 10, not 9. Okay. Alright. If you have any questions about this, just feel free to message me on WhatsApp. Is there any exercise that I can leave you with? Hold on, yeah. That's not really. Oh well. That's no exercise I can leave you with. I hope you guys have already tried the task and understand the example. I would say that this is the easiest one, the easiest distribution. So next, after your exam on Thursday, we'll take a look at binomial distribution. Okay? Binomial distribution is a bit interesting. Okay, so thank you for watching this, and see you guys on Tuesday online class. Yeah, Tuesday online class. All right, see you guys.